Welcome back. I am Charlene and today we are discussing Newton's second law of motion. Exams are easy to beat if you know what exactly to expect. I'll get around to sharing just that with you in a little while, but before that let's just answer that one question on the speed time graph. Now my first question based on this graph was, in which region is the acting force positive? We can see that the slope of line OA gives positive acceleration. So the region OA gives positive force because force is equal to mass into acceleration. Number 2. Now to find out the retarding force. Just consider that the slope of line BC is equal to acceleration, and that's equal to minus 7.5 meters per second square. The negative sign of force means it is a retarding force, and the retarding force is 7,500 newtons. Now moving on to the third part of the question. For how long is there no force acting? From the graph we can see that in the region A to B, the car is moving with a constant speed. Hence the slope of line AB is 0. That means acceleration is 0. Since acceleration is directly proportional to the force, hence during the time interval 4 to 8 seconds, no force is acting on the car. Now knowing all that theory will be of little help without these magic mantras, your key to perfect score.
For the statement of Newton's second law of motion, some students make the mistake of associating the change in acceleration with force and mass, that is F equal to ma, as the correct statement, though the correct statement actually is that the rate of change of momentum of a particle is directly proportional to the applied unbalanced force. Another thing to remember, students, is that whenever you're writing the unit for force, you should always start with a small n. Whenever you're writing the full term, that is Newton, should always begin with a small n. But the unit is specified or designated as a capital N. Another thing to remember, students, is that whenever you're calculating force given the velocity time graph, you should always read the graph carefully so that acceleration can be calculated, and this multiplied by the mass will give you the force. One unexpected question that might be asked students is a graph given in which the momentum is along the y-axis and the time is along the x-axis, and this graph is a straight line inclined to the x-axis, and you're asked to figure out what this graph is all about. A little thought and you'll be able to figure out that the slope of this momentum time graph is nothing but the force. I hope these tips help you in scoring better in the exams. Good luck.
These probable exam type questions with their appropriate mark weightage will help you prepare for your exams. The question in the exam could be, 1. What is momentum? Give its SI units. 2 marks. Why does a cricket fielder pull his hand in the direction of the travelling ball while catching a ball? This is a 2-mark question and we've already done that. You may get this question. If the acceleration of a body is to be doubled, what changes would be made? Normally for 1 mark. Or maybe your next exam question could be a question like this. Which one requires more force? Accelerating 10 gram mass at 5 meter per second square or a 20 gram mass at 2 meters per second square? Again, 1 mark question. The motion of a body is shown in a VT graph. Using the VT graph, find 1. Its acceleration, 2. The force acting on the body, 3. The change in the momentum of a 2 kilogram mass. This question could come for 3 marks. Knowing the right answer is great, but knowing how to answer it right is even better. Here's a look at how to write an ideal answer. When you jump on a concrete surface, your feet hurt more than when you jump on sand. Why? 2-mark question. While answering this question, these are the key points you should keep in your mind. Your feet hurt more because a large force acts on your body due to high rate of change of momentum because the floor is hard. When you jump on sand, a small force is exerted on your body because the time of landing is relatively prolonged. For giving that right answer, you would get 1 mark each. Now let's take a look at another question. A body of mass 1.5 kilogram is at rest. A constant force of 10 Newton starts acting on it. Find the time taken by the body to move through a distance of 100 meters. Normally a question worth 2 marks. Are the key points. In the problem it is given that mass is equal to 1.5 kg, distance is equal to 100 meters and force is equal to 10 Newton. Since body is at rest, hence its initial velocity u is equal to 0. Apply Newton's second law, F is equal to ma, and calculate the acceleration a. 1 mark for this. Now using the second equation of motion, S is equal to ut plus half at square, and by the way, this formula itself is half a mark. Put the values of ut and a and then calculate the time taken t. Half a mark for this. Now do remember these while answering questions from today's topic. Always remember, force is proportional to the rate of change of momentum. Newton's second law says that the acceleration is directly proportional to the unbalanced force applied and inversely proportional to the mass of the body. Focusing on key areas out of a large topic often helps. So here's what you should concentrate on from this topic. Conceptual questions on momentum, Newton's second law of motion, and numerical problems based on F is equal to ma and P is equal to mv. That's still not all from Newton's court. That is yet another law, the third law of motion. But you know where to log on to for any clarifications on any of the laws on topperlearning.com. You can also find online tests on our website. So get acquainted with Newton's laws and keep all motion sickness at bay. And remember, knowledge is light, so keep the doors of your perception open.